We have 2 tests, one today and one tomorrow.
So, slide number 30. So we're just going to look at a few examples for some review. So, this is my nucleus. I have my protons and neutrons here, and it also shows that I have 8 electrons. So would this atom, the way it's showing it, would this atom itself be charged if it has 8 electrons and 8 protons?
Hey guys,
Good.
there are slides and notes. Everybody, you said review, so I don't.
Oh,
think
I'm
they
sorry. Yes, it is.
So,
It's
there's
in your
stuff to fill in.
slides.
Sorry, after I said it the fourth time, I was just gonna interrupt you.
Do it. So if we have 8 electrons and 8 protons, is that atom itself charged? Good, I'm seeing some no's, right? You'd have to be unbalanced, right? You'd have to have either more protons or more electrons for this thing to have a charge. But what is the overall charge in the nucleus here? What do you think? And this is going to help you a lot next year.
Positive,
Yeah, why, Paul?
because it has only protons and neutrons.
Very good. The protons are positive, right? Good. And then what charge do our electrons have, Addie? What's our other one? These are positive and neutral, so what's left? Negatives. Good. And so what do a positive and a negative want to do? Show me with your hands. Very good. So which one of these rings is going to have the greatest charge, like the greatest attraction? This inner ring or the outer ring? The inner ring. Do you have any guess why? Or why'd you pick that?
Because they're closer together.
Very good. This negative is closer to this positive, so they're going to be more attracted than the ones that are farther away. So it's going to be that inner ring. So I think you just circle that, or maybe there's a blank to write it. I'm not sure. And just like Kendall said, because the distance is closer. All right, so now we're looking at magnetism. So is the magnetic force going to be stronger at the outer edge or at the inner edge? And you can see there's tiny little lines kind of showing the magnetic force field there, those force lines. So it's going to be in the inside area or the outer edge of these magnets. What's your best guess there? What do you think, Isaac?
Inner.
Probably the inner, right there. And again, the distance is closer, right? These are opposites, so they're going to attract, and so they're pulling here tight, and here tight, and here tight, and here tight. Here, they're kind of farther away. And last week when you got to play with the magnets, right, if they were too far out of the field, did they attract each other? Or if they were too, when they were stuck together and you wanted to pull them apart, it was harder when they were actually touching to pull them apart, right? So the closer, the more intense they're going to feel that magnetic pull. All right, so now let's look at the gravitational. So to kind of orient you, here's the sun. You can't even get the whole sun in this picture. That's how big, and this is pretty to scale, how large the sun would be, right? We're just seeing a little sliver of it. Then Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Okay? Oops, sorry. Oh, I can't go back. My stupid mouse. There we go. All right, so where is the greatest gravitational force going to be? And Ad's kind of already said this. Go again.
It's the sun.
Because.
It's the largest.
Very good. All right. So all of these planets and all of the moons that go with these planets are going to be revolving around the sun. The sun is the center of our universe, right? So a few of you asked earlier on in this unit, like, well, why is our moon with us then instead of with the sun? And so we'll talk about that here in just a second. But right here is where we're going to have the strongest, largest force. Again, it's the most massive of the objects out there. So we are all in in the sun's gravitational pull, or in its orbit. But if we're just looking at the planet, so we're ignoring the sun, which one of these is gonna have the strongest pull? And you probably noticed this from that gravity exploration, Ronan.
Jupiter?
Yeah, it had the greatest gravitational constant, like maybe 2.8 something, I think. So yeah, Jupiter is gonna have the greatest pull, again, because it's the largest. So hopefully you're seeing that theme. Right, because it's the largest or most massive planet. So when we're saying large or big, we mean it has the largest mass, right? Hopefully you're seeing the pattern, right? The closer, the more intense, and the larger for gravitational, the more gravitational pull it's going to have. All right, so can only moving forces that touch exert a force? Good, I'm seeing like some slight shakes. No, right? The three that we just learned about work kind of invisibly through that force field. So moving forces, not moving forces, touching forces, and forces that are not touching or at a distance can all exert force. Okay, and one last thing. Do we have gravity on both of these locations? On the moon and on Earth? Okay, at least a few of you are giving me the bobblehead. Yes, right, there is gravity. Which one is gonna have more? What do you think, Addison? Is there more gravity on the moon or on Earth? Okay, very good. Why?
Larger mass.
It's a larger mass, very good. And so you can kind of see this blue line, this circle kind of showing the moon's revolving around the Earth. So I think it might have been Henry that said, well, why doesn't the moon go around the sun since, you know, we're saying that the sun is the biggest in the universe? Well, if we look back, if I can get my stupid, oops, wrong way. Here's the Earth, right? And the moon is with us. The moon would be like, in this kind of scale, it'd be almost like touching the Earth. It'd be that close. So why do you think that it follows the Earth instead of just revolves independently around the sun? What do you think would be the reason why? What do you think, Helen? Very good. That distance, right? So even though, so kind of by default, it is revolving around the sun because the Earth is, but it follows us. It follows the Earth because it's closer. Now, if it would get too far away from the Earth, then it wouldn't be part of our orbit anymore. It would revolve around something else, whatever it's closest to. So it's kind of a little bit of a balance between how close is the object and how massive are the objects you're talking about. So it's easy to see, okay, it's going to have less mass because it's smaller, right? But because it's so close to the Earth, even though the Earth is so much smaller than the sun, so it's kind of that balance between those two variables. But both the Earth and the moon have gravitational forces. It's just Earth has more mass, so more gravitational force, like Addison said. And it's going to orbit the Earth instead of the sun, because Kellen is right, the distance is closer. So it's going to be influenced by the nearest object that's large, which is us. And that is where we will stop.